One context for multiplication is repeated addition. For example, when I have 3 times 4, that saying is 3 groups of 4. And when you total that up, there are 12 total. Another way to see area or see multiplication is through the use of area. Drawing a rectangle that is 3 by 4, 3 by 4, and counting up all the squares, there would be 12. Now we shortcut these drawings, and we're going to look at multiplication as partial product. We looked at addition as partial sums. This is going to be partial product. Product means multiply. So I'm going to multiply in parts. I'm going to take and multiply the ones. 4 times 6 is 24. Notice I put the 2 in the tens column. 4 times 1 going across is really 4 times 10. 4 times 10 is 40. Finding the total, there would be 64. If we wanted to see this in terms of area, I'm going to draw a rectangle. And across the top I'm going to make 16. But what I'm going to do is make the 16 a sum of 10 plus 6. Down the side, make this dimension 4. And so area is the space that it covers. So the space filled in this region would be 10 times 4, or 40. Notice the 40 in our partial product. And the area off to the right would be 6 times 4, or 24. Again, the area shown here with 6 times 4 in our partial product. Taking a look at our traditional algorithm, what our traditional algorithm does is simplify this process, and it's just a shortcut. And so when I multiply, I'm going to take 6 times 4 and get 24, drop the 4 in the ones position, and carry the 2 or 20 from the 24 into the tens position. 4 times 1 is really 4 times 10 is 40, plus the 20 I carried over. 40 and 20 is a total of 60. Second problem, similar to the first, partial products. 7 times 8 is 56. Again, notice the 5 goes in the tens position. 7 times 3 is 210. So notice the 2 goes in the hundreds position. Adding these two sums, you get 266. A drawing, again a rectangle. The dimensions are 38 by 7. So when I look at the space involved in the larger rectangle, this area, which is 30 by 7, which is 210. Notice again the 210. And in the far right, 7 times 8 is 56. Again, the 56 shows up in our partial products. It's exactly where those numbers are coming from. It's from the area, the pieces formed in that rectangle. Traditional algorithm says take 7 times 8 and get 56. Put the 6 in the ones column, carry the 5 to the tens column. 7 times 3 is really 7 times 30. 7 times 30 is 210. 210 and the 50 I moved over is 260. And with the ones already in the position, 266. Let's try 2-digit times 8. 2-digit. Partial product is done the same way. 3 times 4 is 12. Now I'm going to go across. So I'm doing this property, which we'll learn later, called the distributive property. 3 times 3, which is really 3 times 30, is 90. Now I've distributed the 3 to both the 4 and the 3 and 34. Now I'm going to do the same thing to the 2. The 2 is really in the tens column, so we're going to say that is 20. 20 times 4 is 80. And 20 times 30 is 600. Finding the sum of these different areas. In the ones there would be a 2. In the tens, these two regroup and make 100. I already had 6, and that extra 100 I regrouped would be 782. Showing area in this diagram, again drawing a rectangle and splitting 30 into 30 plus 4, and 23 into 20 plus 3. Looking at the 4 different areas, notice there are 4 different partial products, multiplying the larger area, 600, matching this partial product. 4 times 20 is 80, again, matching the partial product. Down below, 3 times 30 is 90, again matching, and lastly 4 times 3 is 12. Now if I was to total those up, I'd get 782. Our traditional algorithm shortcuts this process. 3 times 4 in the ones is 12. I leave the 2, put the ones in the 10 column from the 1 on the 12. 12 is made of 10 and 2. 3 times 30 is 90. An additional 1 is 100 and 2. So it's already combined those ones and the 100. 2 or 20, we need to see that as 20 times 4 is 80. Notice there's a 0 on the right. 20 times 30 is 600. So notice I just put the 6 in the hundreds position. It was already held for me, and my total is 782. Last problem. Again, 3 times 4 is 12. Show it using partial product. 4 times 80 is 320. 6 times 3 is 180. 6 times 8, it's really 60 times 80 is 4,800. Totaling my columns, making sure that I carry, which we want to call regroup, the 10s into the 100 and adding those. Notice I'm kind of doing this looking at the 8, the 1, and the 1 to make 10. 10 and 3 is 13. It's really 1,300. Move the 1,000 over, and now it's 5,312. Showing a diagram of area. Again, my rectangle. I'm going to break 80 into an 80 and a 3. 64 into 60 plus 4. Looking at my different regions, I have 4. So they're going to correspond to my 4 partial products. 80 times 60 is 4,800. 3 times 60 is 1,080. 80 times 4 is 320. And 3 times 4 is 12. All 4 of my regions match all 4 of my partial products. The shortcut algorithm, 87 times 64. Starting on the left, 83 times 64. Starting on the left, 4 times 3 is 12. The 2 in the ones position, the 1 in the tens position due to 10 plus 2 being 12. 4 times 8 is 320. An additional 1 is 330, and notice the 2 is already in that position. 60 times 30 is 180. And I'm going to move the 1 up into the hundreds. 60 times 80 is 4,800. An additional 1 is 4,900. Adding my columns. 2 in the ones column. I have 11 in the tens column, which is really 110. Bring my 100 to the 100s column. Adding my hundreds, 900 and 100 is 1,300. Carrying my thousands to the thousands column, 5,312.